This is Anthony Priscilla. We're picking up from our little break in college algebra, and we've been discussing matrices and determinants and linear systems of equations, and now we're going to look at Cramer's rule, which is another way of solving a linear system of equation. All of you have solved linear systems using elimination and substitution in a previous math course. But now we're going to look at Cramer's rule, which is going to involve those determinants and that little crisscross stuff we were doing. So let me give a general outline to how we're going to use Cramer's rule. So let's see. The first thing we'll do is find the determinant. I'm going to use DET to abbreviate determinant. Find the determinant of the coefficient matrix. Find the determinant of the coefficient matrix. Let's call it capital D. Then find the determinant of the matrix formed by replacing the X column of coefficients with the column of constants. And we're going to call this matrix, or this determinant, D subscript X. So you replace the X column, find that determinant, call that D subscript X, and just say define D subscript Y similarly. By that I mean we'll replace the Y column with the column of coefficients. Excuse me, column of constants. Similarly. And then here it is. Here's the statement of Cramer's rule. Now, if you have more than two variables, I'm assuming just a 2 by 2 linear system, two equations, two variables, x and y. If you have a z, if you had three variables, you would replace the z column with the constants. Find that determinant also. But for our illustration here, we're just going to have x and y. And then here it is. X is d subscript x over d, and y is d subscript y over d. Now, whenever we have fractions like this, there's a slight problem if you have a zero in a denominator. So let's make a note. It's possible that Cramer's rule can't be used. Note, if d equals 0, Cramer's rule fails. So you can't use it then. What would you have to do to find a solution? Well, then you're going to have to go back to elimination or substitution. So elimination and substitution. Now, let's look at some of these problems here. Number 8. You'll see that it says use the Cramer's rule to solve the system of equations. And then it makes a statement, okay, if d equals 0, use another method. So you'll have to use something like elimination or substitution then. Okay? But let's see. First thing we'll do, this is number 8. First thing we're going to do is find the determinant of the coefficient matrix. Ooh, wow, what are all those coefficients? You just write down the number attached in front of the variable. So that's a 1. The x column is 1 and 1. The y column would be what? 1 and negative 1? Ooh. Now, do you remember how to do this, find these determinants? You're going to do that little crisscross. Remember, the first diagonal that you use has to have that first number. Do not use this diagonal first. You're going to get the numbers wrong every time. So like this. Negative 1, you're multiplying. Then a minus, always a minus between those two diagonals. 1. No, it's not 0. What is it? Negative 1 minus 1, it's negative 2. I think some of you were thinking that it was going to be right off be one that Cramer's will fail. Well, hopefully on the first one we do, it doesn't fail. So there's D. Now we're going to find D subscript x. D sub x. That means replace the x column with those column of constants. So these are the column of constants, the 9 and 5. Move this up. So in place of the x column, we put a 9 and a 5. Now the y column stays the same. It stays 1 and negative 1. And when you do the little crisscross again, make sure you start with that diagonal that has that first number. Negative 1 times 9 is negative 9. And always a minus between. 1 times 5 is 5. Now be careful, because sometimes that green diagonal might give you a negative number and you have minus and negative. So you want to be careful with that. So negative 14. So just from doing that, we know the solution for x. If we look at the statement of Cramer's rule, x is dx over d, y is dy over d. So we don't know y yet because we haven't found dy, but we know x. Let's see, what's x going to be? X is negative 14 over negative 2. Is that going to be a 7? You already know the solution for x. Now, let's find dy. To find dy, whatever the subscript is, that's the one that gets replaced. To find dy, the y column is the one that's going to get the 9 and 5. The x column just stays as it was originally. Oops. 1 and 1. Now let's do the little crisscross. We have 5. When I do this crisscross, I'm multiplying those diagonals. Minus 9. 5 minus 9 is what? A negative 4? So what's y going to be? Y is dy over d. So negative 4 over negative 2. It's a positive 2. Now you can check your answers by plugging them into the original equations. It should make both of them true. Does x plus y, does that give you 9? X and y. X minus y is 7. minus 2 going to give you the 5? Yeah. So 7 is our x value, 2 is our y value. Let's see how we're supposed to put these answers in here. Well, there's several options. The empty set, infinitely many solutions, and just the solution set that's the one we're going to write. And it says type an ordered pair. So you're going to have to type 7, 2. Okay. You would have infinitely many solutions if you had the same line and it was just one on top of the other. The empty set would be if you had parallel lines. You should have seen some graphical interpretations of that in another course. Okay? Any questions there? Let's do one that has more or some numbers, bigger numbers, other than just so many ones. So this is problem number 9. Same type of problem. Find Cramer's, use Cramer's rule. So what we're going to do is first find D. We'll have an X column and a Y column. 4, 5, 2, and 6. Oh, are y'all caught up with me? Let's see. 4 and 5, 24 minus 2 times 5, 10. 24 minus 10, what's D going to be? 14? So we don't have, so Cramer's rule hasn't failed, so it's going to work. So let's find now D subscript X. With D subscript X, whatever the subscript is, that's the one that gets replaced with those constants. So negative 12, negative 22. Leave the Y column as it is, 2 and 6. So we would have negative 12 times 6. That's a negative 72. Then a minus in between. And what I'd mentioned earlier is about to happen. The green diagonal, 2 times negative 2. There's another negative 44, so you better watch out. The minus and negative becomes a plus. Negative 72 plus 44. Did y'all hear that? It's negative 28. So right now we know the solution for what? Yes, X. So X is dx over d, negative 28 over 14. So X is negative 2. Ooh, look, sounds like it's raining outside. Now what about dy? Well, let's see, what color do I want to do that in? I'm going to do it in this pink color. To find dy, it's the Y column that you're going to replace with that negative 12 and negative 22. Leave the X column as it is, 4 and 5. Now when we 4 times negative 22, that's a negative 88, minus what? Let's see, negative 12 times 5, that would be a negative 60. Yeah, negative 60. So negative 88 minus a negative 60, that's another one of those pluses. Hey, is this going to give us another negative 28? So this is another one where y is negative 2. We better check that. Let's plug negative 2 in for x and y. 4 times negative 2 would be negative 8. 2 times negative 2 would be negative 4. So negative 8 plus a negative 4, is that giving negative 12? Yes. What about down here? Are we getting negative 22? 5 times negative 2 is negative 10. 6 times negative 2 is negative 12. So is 10 plus a negative 12 negative 22? Yeah. So our solution set is the ordered pair negative 2. Negative 2, negative 2. There. Be sure when you type that in, you need to put that in parentheses. Let's see. Let's do number 10. Okay. Number 10, there's a couple of ways of going about it. Okay. There's all those messy fractions. If you want to, you can just jump right on into it. I think it's rigged to work out pretty nicely, even though there's those fractions. If you don't want to work with the fractions, we could solve an equivalent system by getting rid of the fractions. Like on the second equation, what could I multiply straight through by on both sides to get rid of these denominators? 2, did y'all hear that? So you can multiply straight through by 2, and by doing that you cancel these denominators. Why'd I pick on the second one first? Well, what would I have to multiply the first one by if I want to get rid of those denominators? Let's see, I need to get rid of a 2 and a 23. So what's the smallest number that 2 and 23 both multiply into? Both divide into? Well, here's a hint. Multiply 2 and 23. 46. Multiply straight through by 46. Even the 2 gets multiplied by 46. So I'm distributing the 46. So I'm not actually going to solve this system of equation. I'm going to solve an equivalent one. Distributing the 46, we'd have a 23x plus 1 over 23 times 46. 23 goes into 46 2 times. 2 times 1 is 2. And what would we have on the right-hand side? 80 and plus 12, is that 92? Second equation, you just multiply straight through by that pink 2. Let's see, what would we have? We'd have a 23x, because the 2's would cancel, x minus, the 2's cancel, just a 1y equals negative 92 times 2, that's going to be a negative 184. This one looks like it'd be pretty easy to do with elimination, wouldn't it be? Maybe just multiply straight through by negative 1 here. And you can eliminate those x's real fast. But I'm not trying to illustrate elimination. I'm wanting to do Cramer's rule here. So we'll find the D. So D. Write down the x column. 23 and 23. Realize this is the one I'm using now. I'm solving an equivalent system. And you do the little crisscross. Negative 23 minus what? 23 times 2. Is that going to be 46? So negative 23 minus a positive 46, that's going to be a negative 69. Now, what about D subscript x? The x column gets replaced by that column of constants. So a 92 and a negative 184. Hey, you might decide it's easier to work with the fractions than these big numbers, but they're not that bad. 92 times negative 1 is a negative 92. Then minus, what's the green diagonal going to be? Oh, can y'all see these colors here, or do I just sound stupid talking about the green diagonal and it all looks the same color to y'all? 184 times 2, is that a negative? Oh, well, negative 184 times 2. That's going to be a negative 368. Are y'all caught up? Minus and negative is going to be a plus. So negative 92 plus 368. What's that going to give us? 276. So let's go ahead and state the solution for x. X is dx over d. So 276 over 69. Is that going to simplify down to an integer? 4. 69 times 4 will give us 276. So this is negative 4 for x. And I think I'll use purple to find dy. Replace that y column with the 92 and negative 184. And leave the x column with the 23s. Might want to use a calculator to help you with this, these calculations. 23 times a negative 184. Oh, I'm doing the red diagonal. 23 times a negative 184 is a negative 4232. And a minus. Let's do the green diagonal. Oh, can you see what I'm doing? Have I gotten too low? Hopefully not. 23 times 92. Ooh. 2116. So let's see. What's a negative 4232 minus 2116? Ooh, a negative 6348. So this is a negative 6348. So y is dy over d. It's a y there. So negative 6348 over negative 69. Does 69 divide evenly into 6348? What are we getting? 92? Oh, maybe we better check those. I'm getting a negative 4 for x and a 92 for y. So let's see, does that check? I'll plug those in. So I'm plugging into the first equation. 23 times negative 4, just using my calculator, plus 2 times 92. Is that giving me a 92? Yeah, it is. You take each of these and plug them in for x and y. 23 times negative 4 minus 1 times y. Is that giving a negative 184? Yep, it sure is. So we can go back to this equation and say the solution set is negative 4, comma 92. Again, I didn't actually solve the one that was given. I solved an equivalent one, I guess if you wanted to practice your fraction operations, might not be a bad idea to go ahead and set it up using these numbers. 1/2, 1 over 23, 23 over 2 1/2. You still get the same final answer. -4, 92. Okay. Well, I think that's about it for today. And y'all work on your matrices and your determinants and Cramer's rule. And I'll see you the next time as we wrap this up doing the last homework assignment for the semester. Okay, so bye-bye.